We had a problem like this on one of the homework assignments. I think it was the most recent homework assignment, in which we're given f prime. We're trying to figure out where f has a local max, local min, and a point of inflection. Okay, well, we can clearly see that at -2 and +3, hopefully we can clearly see this, that f prime is equal to 0 at both of these x values. So f prime is equal to 0 when x is -2, and f prime is equal to 0 when x is equal to 3. Okay, well, when we plug in a test value, like let's say we plug in -5, the first, hold on one second, not quite sure what I was saying, the answer machine was going on. Anyway, when we pick a test value for x and we replace x with that test value, we can see that f prime, when x is equal to -5, f prime, the first factor is always going to be positive because we are raising that factor to a power of 2. And then -5 minus 3, well, -5 minus 3 is going to be negative. Okay, so we have a positive times a negative, and in other words, we have a negative. Okay, so f prime is negative on that interval. Then in between -2 and 3, let's pick the test value of 0. Again, positive for the first one. 0 minus 3 is negative, and so we have negative again. Okay, so f prime is negative on that interval, and then to the right of 3, finally, f prime is positive, and so therefore f, the function f, is decreasing, then increasing, and so therefore f actually has an absolute minimum, because f is going to look like that. So f has an absolute minimum at x equals 3. So I just got interrupted again and I paused the video, so pardon me if this seems fragmented. But anyway, just a quick review what we just did. Decreasing, increasing. Therefore we have an absolute min, and we're only looking for a local max or a local min. We don't have any local max here because the function is a polynomial function. It's a 4th degree polynomial. F is a 4th degree polynomial. Okay, and so therefore the graph will look like that, and we have no max. So none would be the answer to part A. So for part B, a local min, that's going to happen, like I said, at x equals 3, and we don't know what the y value is, so don't try to find it. And then the point of inflection, well, that's going to require something different. We're going to have to find f double prime, because f double prime is what's going to give us that point of inflection. So if by chance you don't know how to do this, I would encourage you to try to go back to that assignment from section 4.3. I think it was problem number 29, and look at that problem before you try this one. So I challenge you to get this one right after looking at number 29, because I made a video on that one as well. We need to find f double prime. F double prime is equal to the first, x plus 2 to the second power, multiplied by the derivative of the second, which is 1, plus the second, which is x minus 3, multiplied by the derivative of the first, which is 2 times x plus 2. Now this is where some of you got hung up in the last time we did this, where I said, let's go ahead and factor out that x plus 2. So f double prime is equal to x plus 2 factored out. To me, this is the easiest way. I'm not sure about you guys. In fact, it doesn't ever seem like this is easiest for the students. But after we factor out an x plus 2 from the first term, we're left with x plus 2, and then plus 2x minus 6. Okay, that's what we're left with in the second term. And when we combine the like terms on the inside of this next set of parentheses, we get 3x minus 4, and so therefore we see that when f prime double prime is equal to 0, let's write that. This equals 0 when x equals -2 and x equals, I've seen students make mistakes here, I almost did it too. Add 4, divide by 3, so double check that. When x equals -2 and when x equals 4/3. What are we going to have here? So -2 is where we have f prime equaling 0. So all I'm doing here is I'm looking at the graph of what I analyzed to be f of x, and so we would see that when f prime is equal to 0, we actually have a point of inflection. so at x equals -2. And then somewhere in between -2 and +3, where we have a horizontal tangent line, there's another point of inflection, and so 4/3 is in between there, and so I can be reasonably sure that both of my values, -2, and when x equals -2, and also when x equals 4/3, I can be reasonably sure that those two values are accurate because of what I just analyzed and what we just talked about. And so there you have 107.